15 billion miles from Earth. In a realm where sunlight is barely a whisper and our planet is a distant memory, a lone spacecraft drifts through the cosmic void. Voyager 1, launched nearly 5 decades ago, has become humanity's farthest emissary, a silent explorer in the frigid darkness of interstellar space. For years, it sent back whispers of data, faint signals from the edge of our solar system. But recently, after months of garbled transmissions, this aging probe delivered a message that has left scientists stunned. Something out there, at the very boundary of the sun's influence, is rewriting what we thought we knew about the universe. This isn't just a discovery, it's a glimpse into a mystery that could change how we see our place in the cosmos. The journey to this moment began in 1977, when Voyager 1 lifted off from Earth, carrying a golden record etched with the sounds of our world music. Greetings, the heartbeat of a human. Its mission was to explore the outer planets, snapped photos of Jupiter's swirling storms and Saturn's rings, then sail onward into the unknown. In 2012, it crossed a threshold no human-made object had ever reached: the heliopause, the invisible line where the solar wind meets the interstellar medium. This is the edge of our solar system, a frontier where the sun's influence wanes and the galaxy's vastness takes over. Scientists expected chaos here, a turbulent clash of particles and magnetic fields, but Voyager 1 found something else entirely. Over several months, as its faint signals trickled back across the abyss, the spacecraft's instruments, still powered by a fading radioactive core, picked up something extraordinary. The plasma wave system and magnetometer, tools designed to measure the invisible forces of space, detected a magnetic structure unlike anything predicted by decades of models. The heliopause, long thought to be a messy, chaotic boundary, revealed a pattern of magnetic fields that was eerily ordered, almost as if it were designed. These fields didn't churn or scatter randomly. Instead, they rippled and pulsed in a way that felt alive, forming a lattice of energy that seemed to hum with purpose. At first, the data seemed like a glitch. Voyager 1 is old, its systems pushed far beyond their design limits. Engineers at NASA's Jet Propulsion Laboratory pored over the readings, recalibrated the instruments, and cross-checked them with Voyager 2, trailing millions of miles behind on a different path. The results held firm. This was no error. The magnetic fields at the heliopause weren't just stable, they were rhythmic, aligned in a way that defied the turbulent physics of high-energy plasma. Picture a stormy sea suddenly forming perfect, repeating waves, or a scattered pile of sand arranging itself into a geometric grid. That's the kind of anomaly we're talking about. What makes this discovery so baffling is its structure. The magnetic fields form a quasi-crystalline pattern, with oscillations that repeat at precise intervals. In a region where temperatures soar and particles collide chaotically, such order shouldn't exist. The heliopause was supposed to be a battleground, where the sun's outgoing particles slam into the interstellar medium's dense plasma. Instead, Voyager 1 found a boundary that behaves less like a roiling river and more like a carefully woven tapestry. The energy signatures suggest a system that's not just stable but dynamic, as if the heliopause is responding to forces we don't yet understand. Scientists are scrambling to make sense of this. One idea points to the interstellar medium itself. Perhaps the galaxy's magnetic fields, stretching across light years, are interacting with the sun's output in ways we hadn't anticipated. If so, the sun's reach might extend farther than we thought, its magnetic influence weaving a complex dance with the cosmos beyond. Another possibility is even stranger. Could dark matter, that invisible substance thought to shape the universe's structure, play a role? Current theories don't support dark matter creating such precise magnetic patterns, but this discovery is forcing researchers to reconsider what's possible. Some even whisper about gravitational effects from unseen cosmic structures, filaments or walls in the galaxy's architecture that might sculpt these fields. The implications are staggering. If the heliopause isn't just a passive boundary but a structured interface, it could change how we understand the solar system's place in the galaxy. For decades, we've pictured the heliosphere as a bubble, a fragile shield of solar wind, protecting the planets from the harsh radiation of interstellar space. But what if it's more like a membrane, a living boundary that filters and shapes the flow of particles? Voyager 1's data hints at this possibility, showing sharp changes in the flow of cosmic rays, high-energy particles that zip through the galaxy. As the spacecraft crossed this magnetic lattice, certain particles passed through while others were blocked, as if the heliopause were a gatekeeper, selectively choosing what enters our solar system. This filtering effect is unlike anything we've seen in natural astrophysical processes. It suggests the heliopause might regulate the cosmic rays that reach Earth, influencing everything from our planet's climate to the delicate chemistry of life. Cosmic rays can spark chemical reactions in the atmosphere, even affecting cloud formation or genetic mutations. If the heliopause acts as a cosmic sieve, it could play a hidden role in shaping the conditions for life, not just here but in star systems across the galaxy. Suddenly, the edge of our solar system feels less like a wall and more like a bridge, connecting us to the broader universe in ways we're only beginning to grasp. Adding to the mystery, Voyager 1 detected faint radio signals in this region, low frequency emissions that don't match any known solar activity. These weren't random bursts but modulated waves, as if shaped by some unseen force. Their timing aligned eerily with the spacecraft's passage through the most ordered parts of the magnetic lattice. Some scientists propose these signals could be a byproduct of the lattice itself, a kind of resonance humming through the plasma. If true, this opens up wild possibilities. Could these patterns carry information across vast distances? Could they inspire new technologies like propulsion systems that ride these cosmic waves? For now, these ideas are speculative, but they highlight how this discovery is pushing the boundaries of what we believe is possible. The philosophical weight of this finding is hard to ignore. Voyager 1 has traveled farther than any human creation, yet it's shown us that the edge of our solar system isn't an end but a beginning. We've long drawn lines in the cosmos between Earth and sky, atmosphere and space, our star and the galaxy beyond. Each time those boundaries have revealed new layers of complexity. Now, at the heliopause we find not chaos but order, not emptiness but structure. It's as if the universe is whispering that there's more to discover, that our models of reality are just sketches of a far grander design. This discovery also reshapes the future of exploration. If the heliopause is a dynamic, structured region, it could complicate interstellar missions. Spacecraft navigating this boundary might face unexpected magnetic forces, requiring new shielding or guidance systems. But there's also opportunity. These fields could serve as a cosmic map, guiding future probes with their predictable patterns. Imagine a spacecraft surfing the heliopause's magnetic waves, using them to navigate or even harness energy. Such ideas, once science fiction, now feel tantalizingly close. Beyond technology, this finding shifts how we search for life. If other stars have similar structured boundaries, these could influence the flow of organic molecules or cosmic dust, the building blocks of life. The heliopause might act as a gate, deciding what materials reach a planet's surface. Life, in this view, isn't just about what happens on a world but what crosses the invisible threshold of its star's domain. This makes the heliopause not just a scientific puzzle but a key to understanding the potential for life across the cosmos. As Voyager 1 drifts farther, its power dwindling, it's given us a gift, a glimpse of a universe that's stranger and more intricate than we imagined. This isn't about aliens or new physics, not yet. It's about the humility of discovery, the realization that even at the edge of our reach, the universe holds surprises. The heliopause, once a footnote in textbooks, is now a frontier of questions. What shapes these magnetic patterns? How do they influence the galaxy? And what else lies beyond, waiting for us to find? For now, Voyager 1 continues its silent journey, a tiny speck in the vastness. Its discovery reminds us that the universe doesn't end where we think it does. It challenges us to keep exploring, to keep questioning, to keep reaching for the stars. What do you think this means for our place in the cosmos? Share your thoughts below, and let's keep this conversation going. Thank you for joining us on this journey to the edge of the solar system. Until next time, keep looking.